Now that I have some operations programmed, I want to make sure my toolpath looks good using a built-in stock simulation. I can simulate a couple operations by holding Control or Command and selecting the desired operations, right-clicking, and selecting Simulate. Alternatively, I can choose Simulate from the Actions panel of the toolbar. I can simulate an entire setup or multiple setups in the same way. In the stock simulation environment, there are play controls and a timeline at the bottom of my screen, and to the right, the simulation dialog box. The Display tab controls the display settings, which is where I'll start. In the first section, Tool, I can toggle the visibility of the tool and choose between viewing just the flute, the shaft, or the entire tool and holder. I can also enable transparency to be able to see through the tool and holder if desired. I'll check the box next to Toolpath to enable the toolpath display. Under Mode, I can choose how much of the toolpath I want to view, including something called Tail. Tail displays the toolpath for a fixed distance after the tool. I find that viewing the entire toolpath can be confusing. Even displaying just one operation can get a bit crowded. I'll use Tail to keep things simple. Finally, under Stock, I'll make sure this is enabled because this is the most important part, what my stock will look like as I machine it. I can set the mode to Standard or Fast. If I want to simulate anything more complex than 3-axis, I need to make sure Standard is selected, and I would recommend having Standard selected as much as possible. Next, I can choose from 5 materials available in both modes. I prefer ceramic. It's a neutral color and matte, which I find easiest to look at. I'll kick off the simulation by hitting play at the bottom of the screen to better see the colorization choices. Fast mode affords a lot of colorization options. These color the stock based on the parameter, like the direction the tool is moving or whether the cut is climb or conventional. Fast mode allows quality adjustments, so for less powerful graphics cards or a really long toolpath, the simulation is faster. Or I can up the quality to extreme to get a better quality simulation that still uses less resources than standard mode. When I switch to standard mode, the quality option is removed. The colorization options are limited as well to material, operation, and tool. I prefer operation. I also get a new option at the bottom, Stop on Collision. This forces the stock simulation to stop if a collision is detected, and I'll see why that's important shortly. In the next tab, the Info tab, I get detailed information about the current operation. The top portion is a live display that basically mirrors what I would see on a machine controller. The next section shows more general information about the operation. Finally, Verification shows the total number of collisions and the start and finish volume of the stock. The number of collisions is calculated in the background, with the % complete displayed next to the running total. Collisions also appear as red bars in my timeline. I can hover over any section of the timeline to see information about that operation and hover over a red bar to see more about that collision. Like here, I can see the holder collided with the stock. I can click on the timeline to jump directly to that point in the simulation. The stock is colored red, showing me that the area was involved in the collision, but it was still a bit hard to see. I'll turn on Stop on Collision so that Fusion stops at the exact moment of the collision. I can hit play to continue, and the simulation will stop at the next collision as well. In the final tab, the Statistics tab, I see information about the entire simulated toolpath, like the estimated cycle time and number of operations and tool changes. I can use the play controls at the bottom of the screen to play or pause the simulation, move forward or backwards by one move, one operation, or jump to the beginning or end of the toolpath. The slider underneath can speed up or slow down the simulation and even run it backwards. One final trick of the stock simulation is I can right-click to get to a contextual menu. At the very bottom under Stock, I can choose Save Stock to locally save the current stock out as an STL. Now that I've seen the stock simulation, I can see I have some collisions to fix and I need to add a roughing operation to the boreholes. So I'll go back and make those changes before I get ready to post my code.